Okay, so here's the configurations as we've been taught to write them. Here's coppers, here's chromiums. This is the rules you've been taught to play by. And if you put that on a test, I would be perfectly fine with this as your answer, okay? Because it follows the rules. But for the sake of knowing some of the exceptions that can exist, this is not what happens in real life, okay? In real life, copper turns this 2 into a 1. It takes away 1 electron from the 4s, and it moves it up here to the 3d and turns that into 10. If you think about the aufbau diagrams that we just did, you know how we had like the 4s here, and then we had the 3d, right, with our little orbitals? Yeah. What that would do is it would fill up the 3d instead of the 4s. Which one of these is higher in energy? That one. This one, the 3d? Yeah. Okay, by filling this one up, it makes it more stable. And if you know what stability means like it's not as crazy to react with stuff. It's better off being by itself. And if you know, like y'all think about copper, we have a lot of copper, just pure copper all around us, right? Copper pipes, there's copper fittings. Copper's not a very reactive thing. This makes it more stable. What it does, the words you can use is it promotes one of the 4s electrons up to the 3d. You want to take a guess what this one does? It's very similar. Any? Yep, the 2 becomes a 1, and the 4 becomes a 5. It takes 1 out of the s, promotes it to the 5. Now what that does, again, if 4s is down here and 3d is right here, we just drew these. What that does is it puts 1 electron in every single orbital instead of having one of them left empty. Because we just said electrons, they want to try to be as many as possible spinning the same direction, and that's more than it was before. This is more stable than 4s2 3d4. Okay, so what I want you to be able to do for tests out of this is just simply recognize that sometimes atoms are more stable to have a partially filled lower level and a completely filled upper level, or to have 1 electron in each orbital, that they can actually kind of disobey the rules. Okay, and we were looking, I had this up here a while ago, I still have it, not the chapter 5 notes, but here is chromiums. Does that match up right there with what we just did? And here's coppers. That also matches up with what just happened. And if you keep looking, like here's another one. Molybdenum did the same thing. It promoted the S up to the D. It should have been a D4. Commonly, it's those elements that occur in the same columns that those are in, like the D4s will turn themselves into D5s, and the D9s can turn themselves into, D10s. Here's one that moved 1 up from the S at the bottom and turned it into D7 instead of D6. There's not always a rhyme or a reason, but are they basically doing the same thing each time, taking 1 out of the S and bumping it up? Yeah, okay. Am I expecting you to do that? Do you have to do this on a test? No, on a test, would I expect you to know to do that? No, I would expect you to probably tell me 5s2 4d4, and I'm okay with that. We're going to focus on the rules and know in the back of our minds that there's some exceptions. We go with that? Okay, we'll stop this one.